Hello guys, so in this lecture we are going to talk about how to insert an element in a max heap. Okay, so what we are going to do, we are going to implement this insert function. Okay, we are going to implement this insert function in this lecture. Okay, so let's just start with the lecture. So let's say that we have we have a max heap here. Okay, of having 6 elements. Okay, so let's suppose this is a max heap. A max heap is always a complete binary tree, right? So this is the left child of it, and right child is not present because the size is 6. So 1 2 3 4 5 6. Okay, now let's say the elements that we are having is 2 5 7 9 11 and minus 3. Okay, now in the max heap we already know that the maximum element will be at the top and the minimum will be at the bottom. So 11 is the maximum. Okay, so 11 is stored as the value of the root node. Okay, then we have 7 and 9, right? So we can place them like this, or the values can be exchanged as well. Okay, 7 can come here, 9 can come here. Okay, but we have to make sure that the childs of these nodes should be should have smaller values than the node itself. So 9 should can have the child as 2 and 5, and 7 can have the child as minus 3. 7 can also have, if there was 7 at the place of 9, then even then it would be a complete but it would be a max heap, right? So this is what the structure of a max heap looks like. Okay, so now how do we insert in the max heap? Okay, so there is nothing but a small change. Okay, we have to just implement this small change within the insert function of the min heap to obtain the insert function of a max heap. Okay, so yeah, to obtain the insert function of a max heap we have to make a small change in the insert function of the min heap. So let's get back to the insert function of min heap. Okay, so what was the insert function? The insert function was something like this. It was a void function because it won't return anything, right? It would just do the so it would just do the task that is assigned to it. So let's say we want to insert x. Okay, so how we used to write the insert function of the min heap? We used to write it something like this. Okay, so what we used to do, first we used to check whether if size is equal to capacity. Okay, whether the size is equal to capacity or not. So if this is equal to capacity, then we used to simply return, right? Because we cannot we cannot insert any particular element in a heap if it is completely filled already, right? But if not, what would what we would be doing is we would increment the size. We would insert this element at the last index, size minus 1 equals to x, and then what we used to do is for loop. We used to run a for loop from the last index. Okay, size minus 1 is the last index, right? While I is not equals to 0 and arr of parent of I is greater than arr of I. Okay, is greater than arr of I. mm, okay, there should be a semicolon as well, right? Okay, uh, we used to swap, right? We used to swap arr of I with arr of parent of I, right? Parent of I. Okay, we used to swap these, right? And I equals to, we used to uh, give the value as parent of I to it, right? So this was the function to implement that we implemented in the case of insert function in the min heap, right? This was the insert function of the min heap. Okay, now for the max heap, what we'll do is that we would just make a small change here. We'll just change this uh, the operator, comparison operator, whatever we call it, the greater than operator with the less than operator, right? So this is the only change that we have to perform, and now it becomes the insert function of a max heap. Okay, now it becomes the insert function of a max heap. Okay, now let me tell you how we insert the elements in the max heap using this function. Okay, so let's just increase the size of the page. Okay, so let me just move it a little bit. Okay, or we should make use of it and we should do it in the next page. Okay, so let's suppose we are given 5 elements, and the elements are just like this. Okay, so 2, 9, 5, 7 and 11. Okay, so these are the elements. We have to insert these 5 elements into a max heap. Okay, so let us draw a max heap. Okay, so let us increment this. Okay, now let us move this. Okay, now let me draw a max heap. Okay, so let's suppose this is the root node. Okay, let's suppose it has childs. Okay, now the first element that we are going to insert is insert 2. Okay, insert 2. Okay, we'll already assign the capacity to be 5 because we have to insert 5 elements, right? Let's draw the array also. So this is going to be the array. Let's say, okay, let's say this is the array 1, 2, 3, 4 and 5. Okay, so let's give them index 0, 1, 2, 3 and 4. Okay, now when we do insert 2, okay, initially the size is going to be 0 and the capacity is also going to be 0. Okay, so sorry, not 0, actually capacity is going to be 5 because 5 element it can store, right? We are already going to assign it the capacity of 5. Now remember that this is a max heap. Okay, now when we try to insert 2, what happens is that uh, first we check whether size is equals to capacity. So size is not equals to capacity, so what we'll do, we'll increment the size, so size becomes 1. Okay, size becomes 1, and now we'll assign ARR of size minus 1, which is ARR of 1 minus 1, that is 0. ARR of 0 equals to the value that we want to insert. So 2 we want to insert, right? So we'll assign 2 to it. Okay, so ARR of 0 becomes 2, and here also this index represents this represents index 0, 1 or 2, this represents 3, and this represents 4, right? Now when we try to insert element at index 2, index 0, so 2 will be inserted here, right? Now we have inserted 2 at the 0th index, right? So size has become 1 now. Okay, now when we try to insert, when we give insert, when we make insert call for the second element, which is 9, right? 9. Okay, but before that, let's undo all of this. Okay, we have assigned the value ARR of size minus 1 equals to 2, then we'll also have to run this for loop, right? So the size is 1, right? So I becomes for int I equals to 0. Size minus 1 is 0, right? Size is 1 and 1 minus 1 is 0. Now I should not be equals to 0, but I we have assigned already as 0, so the condition is not satisfied. Okay, one of the two condition is not satisfied because and here, right, both the conditions should satisfy. So one of the condition fails, hence the statement within the for loop won't be executed, and this function terminates. Okay, so let's just erase this. Okay, let's just erase this. Okay, now let's get back. Okay, and let's insert another element. Okay, insert 9. Okay, this time we are inserting 9, which is the second element. Okay, now we'll check whether size is equal to capacity. So size has now become 1, right? So size is not again equal to capacity, so size again increases, so size becomes 2, and the capacity remains as it is. Capacity is 5 only, right? Now what we'll do, we'll assign ARR of size minus 1, that is ARR of 2 minus 1, that is ARR of 1 equals to 9. Okay, we are going to assign it 9. Okay, so ARR of 1 becomes 9. Okay, let's assign it the value 9 for now. Okay, now what we'll do inside the for loop. Okay, for int I equals to size minus 1, so size is 2, size minus 1 is 1, so I becomes 1. Okay, now looking at the condition, yeah, so now looking at the condition, I does not equals to 0. This condition satisfies because the value of I is 1 here now. Okay, so this condition satisfies. Okay, and what is the another condition? So the another condition is that ARR of parent of I, if ARR of parent of I, so I is 1, okay, the parent of I is 0, right? Index 1 has the parent index 0, right? Root, so parent of I becomes 0. Okay, so whether ARR of 0 is less than ARR of 1. Okay, so if this condition is true, okay, if this condition is true, let's check. Okay, so ARR of 0 is 2, and which is less than ARR of 1, that is 9, right? You can check it here. So ARR of 0, this is ARR array, right? So this is the array. So ARR of 0 is less than ARR of 1. So we are going to swap these elements. Okay, so what happens is that after swapping 9 comes here and 2 goes to the second index, 2 goes to the first index 1, right? So swapping takes place, and after swapping I becomes parent of I, so I becomes 0, right? The parent of index 1 is 0, right? And now in the second at the second at the second time when the loop runs, so I is already 0, so this condition fails and the loop terminates. Okay, now for the third case, so let's check for the third case. So third case is we are trying to insert 5, right? We are trying to insert 5. Okay, so insert 5 now. Okay, now to insert 5, if you want to insert 5, what we'll do? Okay, so again the condition runs. So what happens is that the size is not again equals to capacity, right? Size is 2 and the capacity is 5. Okay, now again the condition fails. So size is 2, capacity is 5, size is less than capacity. So what happens? ARR of size minus 1, size is increased. Okay, so first I forgot that. So size plus 1, which is 2 plus 1, that is 3. Okay, size becomes 3. Now ARR of size minus 1, that is 3 minus 1, that is 2. ARR of 2 1 becomes equal to the value, right? So ARR of 2 becomes 5. So we'll insert 5 here for the time being. Okay, now we'll check. So for int I becomes size minus 1, right? So 2 I does not equals to 0, and we will also check for the another condition, right? So ARR of parent of I, so I is 2, so the parent of I is going to be 0, right? Whether ARR of 0 is less than ARR of 2. Okay, so whether this condition exists, so let's check. So 2 ARR of 0 is 9 now, right? I forgot to put the correct value here. So ARR of it is 9 here, right? ARR of 0. So whether ARR of 0, which is 9, is less than ARR of 2, which is 5. This is not correct, right? So the statement won't be executed, within the for loop won't be executed, and I now becomes the parent of I, which is 0. Okay, so in the next when the next at the next time when the loop runs, I does not equals to 0, this condition fails and hence the loop terminates. Okay, so yeah, it will only run one time. Okay, now moving on for the fourth case. Okay, for the fourth case, uh, insert. Now we are going to insert what we are going to insert. Let's check. So we are going to insert 7 now. Okay, so for the case insert 7, what happens is that size has become 3 now. Okay, size is 3 now. So let's see. So size, we'll check whether size is equals to capacity. So size is again not equals to capacity, so size is increased. Now size becomes 4. ARR of size minus 1, that is 4 minus 1, that is 3, becomes equals to 7, because we are trying to insert this element 7, right? So ARR of 3 becomes 7. Okay, let's put it here. Okay, so ARR of 3 becomes 7 now. Okay, now we are going to run the for loop. So for I is equals to size minus 1, so 3, I does not equals to 0, this condition satisfies. Okay, and we also have to check ARR of whether ARR of parent of I, so parent of 3 is 1, right? Parent of 3 and parent of 3 ARR of 1 is less than ARR of the index itself. Okay, so let's check what element is at index 1. So 2 is there at index 1. Okay, so whether 2 is less than ARR of 3, what element we have assigned at ARR 3? So 7 we have assigned, right? Here also you can see ARR of 3. So whether this condition satisfies, yeah, so this condition is true. So the swapping will take place, right? So what happens is that we'll erase these. Okay, so this array element at index 1 and element at index 3 gets swapped. Okay, 7 comes here and 2 comes here. Okay, so what happens is that 7 comes here and 2 comes here. Okay, now moving back. Okay, so I now becomes parent of I. So parent of I now becomes parent of, what was the value of I? 3. Okay, so parent of 3 was 1, right? You can see here. Okay, so index 3 has the parent 1, right? Okay, now the value of I is 1 for the next iteration, right? So we'll check whether I does not equal to 0. Yeah, so this condition satisfies. Now we'll check for another condition, right? So whether ARR of 1 is less than ARR of 0. Okay, ARR of 0. Now let's check. So ARR of 0 was 9, right? So this is 9. Whether it is less than 9. Okay, whether this condition, whether ARR of 0 is greater than ARR of this ARR of 1, right? Oh, sorry. I got it wrong here. Okay, so it should be ARR of 0, whether ARR of 0 is less than, whether ARR of 0, ARR of parent of I, right? So parent of 1 is 0, right? ARR of 0 is less than ARR of 1, whether ARR of 0 is less than ARR of 1. So ARR of 0 is 9, whether 9 is less than 7? No, this condition is false, right? So the for loop terminates. Okay, now we'll check for the last case. Okay, we'll check for the last case. So for the last case, size has already become 4, right? Now we'll again check whether size is equal to capacity. So size is 4, capacity is 5. Again the size is not equal to capacity, so size is increased, size becomes 5. Now capacity also becomes 5. Okay, capacity also becomes 5. What we'll do, will assign size minus 1, that is ARR of 4 equals to the last element, right? We are trying to insert the last element. I forgot to make the call. So this is the call for insert 11, right? The last element we are trying to insert now. So on doing this, okay, let's just draw a line here. Okay, so these are the function call. Okay, so when we are trying to insert this, okay, ARR of 4 becomes 11, right? Now we will check, we'll run the for loop for I equals to int I equals to size minus 1, which is 4. I does not equals to 0, whether this condition is true. Yeah, so this condition is true. Now we'll check whether ARR of parent of I, so parent of 4 is 1 itself, right? You can check here. Okay, so parent of 4 is 1, right? Having index 1, right? So yeah, so whether ARR of 1, ARR of parent of I is less than ARR of I, ARR of 4. Okay, so let's check ARR of 1 in the array, because we have inserted, so ARR of 1 is 7 and ARR of 4 is 11, right? We have inserted 11 here. So now we will again check. Okay, so what we are going to check now, whether 7 is less than 11. So this condition is true, right? Both the conditions are true, so swapping will take place, right? So what happens is that in the array will erase this. Okay, so what happens is that 7 goes to the 4th index. Okay, 7 goes here and 11 comes to the 2nd place. Okay, now uh, we'll check again, okay, this swapping takes place. Now I becomes parent of I, so I was 4 initially, now I becomes equal to parent of I, which is 1. Okay, okay, so now I becomes 1. Okay, for the second case, I is 1, I is again not equals to 0, and ARR of parent of 1 is 0, right? Whether ARR of 0 is less than ARR of 1. So ARR of 0 is 9 and ARR of 1 is 11. So whether this condition is true? Yeah, so this condition also satisfies. So again the swapping will take place between 0 and 1 index. Okay, so let's move again. Okay, so 0 and 1. Okay, so these two elements are swapped. So 9 goes to the first index, to the index 1, and 11 goes to the index 0. Okay, so 11 comes to this position and 9 goes to this position. Okay, yeah, so now, okay, now what happens is that I becomes equals to parent of I is 0. Now for the third iteration, the loop will terminate because this condition is not satisfied, right? I is equal to 0 and we want I does not equal to 0. So for loop satisfies, and this is the order, in which the element are stored in the max heap. Okay, when we view them in the max heap itself, so the element will be something like this. Okay, so let's erase this. Okay, 9 won't be stored here, right? So now the final order is 11, then 9, then 5 at the index 2, at index 3 we have 2, 2, at index 4 we have 7. So this is the order in which the element are going to be stored in the max heap. Okay, this is the max heap, and the uh, this is the input that we are going to pass. Okay, and what is the output that we are going to receive? We are going to receive 11, 9, 5, 2 and 7. Okay, so this is the output that we are going to receive after inserting all the elements in the max heap. Okay, 11, 9, 5, 2 and 7. Okay, and you can check, okay, from here you can check that all the element have the child elements, the value of the child element lesser than the value of the node itself. So 11 is the root node, the child of 11 are having values 9 and 5 which are less than 11. Okay, 9 has again two child nodes and both of them have value less than the node itself. So 9 is the value of the node, 2 and 7 is the value of child node, which are both are lesser than the 9 itself, right? So this is what this is the order that we are going to obtain. Okay, so this is the output. Okay, let me write, this is the output, and the input we have to take care of the order also, okay, in which we are inserting element. Otherwise these element will be swapped in the same level. Okay, so the order of insertion will be 2, 9, 5, 7, 11. Okay, let's see whether we get this output after inserting. Okay, let's try to implement the max heap. Okay, so max, let's write a program again. Okay, so we are going to write the boilerplate code first. Okay, namespace standard. Okay, int main. Okay, now let's say we are going to write a class, right? So okay, we are going to name it heap. Okay, access modifier will be public. Okay, now it will have size, it will have capacity. Okay, it will have an array, right? Okay, not an array but a pointer to an array, right? Now the constructor function will look something like this. So we are going to pass the capacity already. Okay, so capacity equals to c, size is going to be 0 assigned initially, right? Arr equals to new integer array, right? New integer of array of size 6, sorry, size c. Okay, capacity c, not size c actually. Now what we are going to do, so we know that int left of any index will be returning 2 into I plus 1, right? Okay, similarly right will be of an index I is going to return 2 into I plus 2. Okay, int parent is going to return I minus 1 divided by 2. Okay, yeah, but this is fine. Okay, now finally we are going to implement insert function. Let me write the comment, insert function to insert the element within a max heap. Okay, okay, now void insert, this will be a void function, right? Int x, let's say the element we are going to insert is x. Okay, so if size equals to capacity, this is the condition, right? We have to check, then in that case we have to just simply return, otherwise we'll increment the size. Okay, we are going to assign size minus 1 as x. Okay, now we'll run the for loop, right? So let's just, okay, int I equals to size minus 1, I does not equals to 0, and arr of parent of I is less than arr of I itself. Okay, then what we are going to do, we are going to swap arr of I and arr of parent of I. Okay, we are going to swap this and I becomes parent of I. Now I becomes parent of I. Okay, so this is the function that this is the okay, so let me write the semicolon here. So this is the function for the inserting values within the max heap. Okay, so now let's create the max heap through static allocation. Okay, so static allocation of the memory. Okay, we'll create an object now. So heap m max, let's say we name it max. Okay, let's say we name it max heap only. Okay, let's say we give it a size 5, okay, because we are implementing the 5 sized max heap, right? So if we give input to the max heap in this order, right? 2 9 5 7 11. Let's just try to insert, okay. So max heap dot insert 2, okay. Okay, first element was 2, second was 9, then 5, then 7, and then 11, okay. Now we have inserted the element. Let's try to check what is the order in which they are stored, okay. I is less than m dot capacity, right? I plus plus, okay. Cout m dot arr of I, right? Let's see what is the order in which we receive the elements, okay. So this is max heap and not m, okay. Max heap, and this is also max heap, right? Max heap, okay. So let's just check now, okay, how we get the elements. So according to our our dry run, we'll get the element 11 9 in the order 11 9 5 2 and 7, okay. Let's just check the order. So upon executing the code, 11 9 5 2 7. So let's just check 11 9 5 2 and 7. So we got the correct output, okay. So this is how we are going to store the element in a max heap, okay. Yeah, so this was all about the lecture, okay. Hope to see you in the next lecture.